Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on threesome. We have to find out the triplets from the given array whose sum is going to result into 0. Let's jump into the problem statement, understand it and start solving. So last time we have solved the longest substring without repeating characters. We'll mark it checked. You can check it in the list. Let's start with threesome. Okay, let's go through the problem statement. So firstly, before solving this threesome problem, there is one more problem in our grind 75 list, that is twosome problem. That was actually, I think, the first problem. I would suggest go through it once and it will make more sense than to commit to threesome. Okay, now given an integer array nums, return all the triplets num I, num j, num k such that I not equal to j, I not equal to k and j not equal to k and nums I plus j plus k equal to 0. So we have to find out triplets, okay, whose sum is going to be 0. Notice that the solution set must not contain duplicate triplets. So we have to avoid the duplicates as well. Okay, so we see -1 is there, 0 is there, 1 is there, 2 is there, -1, -4. If we have to see before solving it, so I would suggest take a minute, think of an approach that you are going to take and then start solving. Ready? Okay. So if we see -1, I add 0 to it and then I add 1 to it. The total sum is 0. This is one of the solution, right? Now next solution is -1 and -1 and 2. But how will we reach to this solution? What we can do is, since we have to avoid the duplicates as well, why not first let's sort the array. So we have our array like this. We'll pick this, okay, and then we'll sort it. Okay, after sorting it will become -4 comma -1 comma -1 comma 0 comma 2. Right now if I start from here, now since we need 3 members, so we can consider 3 pointers. We can consider 3 pointers, right? Maybe I, j, k, left, right, center or anything. So first pointer is at -4. Okay, second is at -1. Let's keep the last one at 2, so that we'll have if the summation is smaller than 0, we'll move this pointer, because so that it will move to the bigger numbers. If the summation is bigger than 0, we'll reduce this pointer and we'll keep first pointer constant. Once that complete loop is done, we'll move to this we'll move the first pointer. Okay, let's say first pointer is at -4, so we'll check -4. Next pointer is at -1 and the third one is at 2. So -4 plus -1, that is -5, plus 2 is -2, that is less than 0. So we'll move this pointer, it comes to -1. So in order to avoid the duplicates, at first when we reach here, we'll check if the next number is same as this number, so that it gets removed in the duplicates, and we'll directly start from the next number. So this one gets removed, we start with 0. So -4 plus 0 plus 2 is still less than 0. We have to move this pointer further, but then it has already reached the last pointer, one step before the last pointer. So solution does not exist in this case. We'll move our first pointer to -1. Okay, now our first pointer is at -1. Next pointer will start at one step ahead, and third pointer will start from the last. So -1 plus -1 plus 2 is equal to 0. Yes, so we'll return the value of first pointer, second pointer and third pointer. So we can run a for loop for the first pointer and call it I, and then we can have 2 pointers taking from left side to the right side. Now when we are at -1, since we took the other -1 with I and the last one with j. Okay, sorry, left pointer, right pointer, and this was I. We found the solution -1 -1 2. We added to the list. So we need a list to store our solutions. Next, since it's already 0, reducing this number on the right will not make make it less than 0. Moving this number further will make it more than 0. So we don't do it. We go for the next one. Now we are at 1, right? Oh, before minus 1 0 2, when we were at minus 1 here, we had find minus 1 this one and we had added to 2. Okay, minus 1 2. Okay, have we missed any number? Yes, we have missed one number. One number was supposed to be here, 1 and then 2. Okay, so we got the solution. Our pointer was at minus 1. We checked with left pointer as minus 1, right pointer at 2. We found the solution. Next, we still move further. Okay, we keep the I constant. We move this one. Okay, it moves to 0 and the right pointer will stay at 2. So minus 1 plus 0 plus 2 is minus 1, right? So it is it is 1, so it is bigger than 0. Will reduce from the right side. Right side will come to 1. So we will have minus 1, 0 and 1. That will be our next solution. Similarly, we'll keep moving forward. So what we need is, first we need 3 pointers, and out of those 3 pointers, 1 pointer will keep it via for loop and 2 pointers, right, which we can run via while loop. Secondly, we need a list to store the results, and also before doing any of this we need to sort the array to avoid duplicates and to solve this problem in a simpler manner. So let's consider all of these and start solving the problem. Please pay attention, and please, I would suggest it again to go through the 2-sum problem and then come to 3-sum problem. Okay, let's start with the problem statement. What is our first requirement? First requirement would be, I'll also comment, first requirement would be, let's create a list to store the solution. List of list, like the way they have given, integer, result is equal to new array list. Okay, now we'll sort the array, right, to not remove the to remove duplicates, no, to easily handle duplicates, and also to use a 2-pointer approach, because we are going to use one for loop and then 2 pointers, right? Why 2 pointers? Because since they are in increasing order, we know if the sum is less than 0, we move this one. If the sum is greater than 0, we move from the right pointer. So to easily handle duplicates and to use 2-pointer approach. Okay, so we can say arrays dot sort, and let's sort this array nums. It is sorted now. We'll say int n is equal to nums dot length. Sorry, this is not needed. Okay, now let's start with traversing. So we'll iterate through the array. Okay, first pointer, so with for loop we'll fix our first pointer on the starting side with I, and we'll use 2 pointers. So we'll iterate through the array. Let's fix the element. Fixing fixing one element, that will be nums of I will be our fixed element, that will be run through the for loop, and we'll keep 2 pointers for the other 2 variables at a time, right? So we'll say for int I is equal to 0, I is less than n minus 2, because we have to leave 2 spaces for other 2 pointers as well, I plus plus. Okay, now we'll skip the duplicates. How will we skip the duplicates? Just in case if after minus 1 there is another, let's say 4 was not here, after minus 1 there is another minus 1, right? So the next, from next minus 1, if we see another minus 1, we need to skip it. First minus 1 we have to consider it. Okay, so we'll say skip the duplicates to avoid duplicate triplets. So we'll say if I is greater than 0, so that we don't consider the first number, and nums of I is equal to nums of I minus 1, right? So that we have 2 ones, and from this point forward we can check that already our I was there and we have already considered it, right? Already a similar number was there and we have already considered it. So from next step of I, we'll check for the back. So nums of I equal to I minus 1. So if this happens, we'll simply say continue. Because earlier we have already considered this minus 1, now we don't need to consider this minus 1. Okay, now use two pointers. Now we'll use two pointers, we'll call them left and right. Why do we need to use them? To find the other two elements, right? We'll say int left. Now left is going to be, I is here, so left is going to be one step ahead of I, so it will be I plus 1. Right is going to be in the right hand, int right is going to be n minus 1. Okay, now we'll start while. Now we are moving first pointer using the for loop I plus plus. We'll move other two pointers left and right in this while loop. So I is here, sorry, in sorted array, I is here, left is here, right is here, and we'll keep moving them. Okay, so we'll say while left is less than right, so it has to be less than right, right? And then we'll check for it. Int sum is equal to nums of I, our first pointer, plus nums of left, our second pointer, plus nums of right, our third pointer. Okay, we found the sum. If sum is equal to 0, that would mean that we have found our solution, right? So we can say found a triplet, add it to the list, or let's say call add it to the result, right? So we can say result dot add. It's what does our result look like? It's a list of integer, right? So we'll say result dot add arrays dot as list. We need to add the elements as list, nums of I, nums of left, and then nums of right. Right, now we have added this one, and let's say this is minus 1, and 2 is one of the solution. But after this there is one more minus 1. We consider this as I, this as left pointer, and this is right pointer. But we don't want to consider this, right? Otherwise we'll have duplicate of triplets again, because next solution would be minus 1, and 2. So we need to move this left pointer and avoid all the duplicates. Okay, so we'll say skip duplicates for the left pointer. Okay, so we'll check while left is less than right, and nums of left is equal to nums of left plus 1, right? And we'll skip all of them and call left plus plus. So this one will get skipped. All the later ones, if there was one more minus 1, will get skipped with this approach. Similarly, we need to skip what if there was a 2 before this 2. Our first solution was minus 1, and 2. If we move from the right pointer to first, here we'll get one more solution as minus 1, 2. So just like we skip for the left pointer on the left side, we have to skip it for the right pointer from the right side. So we can call it skip duplicates for the right pointer, right? So we'll say while left is less than right, and nums of right is equal to nums of right minus 1, right? Because we are coming from right side to left side for the right pointer, right minus. Okay, we have done this. So far everything is clear and plain and simple, right? Now what do we need next? Let's say what we need next is we are moving from left side, we are moving from the right side. Once we have considered the elements and removed the duplicates, we need to move forward to the next unique elements. So we'll do the left plus plus and the right minus. Okay, or I'll comment it as, okay, move the pointers to the next unique elements. So left plus plus, right minus. That's it. Else if So this was when the sum is equal to 0. If sum is less than 0, so if sum is less than 0, that means we need to add a bigger number. So when our left pointer was here, right? We need to move the left pointer to bigger number, which is 0, or it could be any bigger number, right? So if sum is less than 0, we can say if sum is less than 0, move the left pointer to increase the sum. So we can say left plus plus. Else, this else would mean that the sum is greater than 0. So if sum is greater than 0, move the right pointer to decrease the sum. Okay, so we can call it right minus minus. And in the end, when we are done with all the loops, we can simply return result. That's it. Let's run it. I know the problem was slightly complicated. Oops, we are getting some errors. Let's solve them. What happened here? Line number 29. Always somewhere we find a typo. Let's see what has happened. We don't need this. Run it again. Okay, we are seeing cannot find symbol. Oh, the spelling mistake. integer, integer, right? Let's check. Okay, it's working so far. So I know the solution is, or the problem is slightly complicated, but it is not very difficult. Okay, that's why it comes under the medium category. I would suggest go through the 2-sum problem, come back to this one, and then solve this 3-sum problem. It is going to help you massively. Plus, this is a very frequently asked interview question. Okay, yeah. So if you look at the result, we have solved it in 6 speed, 66.98% of the users. So there might be a better approach than this one. This is very commonly approach used for 3-sum problem. I cannot think of any better solution or the approach at the moment, but if you guys have any, please let me know in the comment section. Okay, that is all from today's video. Please like, share and subscribe. For anything, please comment in the comment section. Thank you everyone.